Welcome to Monochemistry. Today we're going to talk about electron configurations, and the first thing we need to look at is just a quick introduction to quantum numbers. I'm not going to get into a lot of detail about this, but I wanted to give you the background information. So the first thing I want you to be aware of, and you already are probably, is that atoms contain electrons that are orbiting around the nucleus of protons and neutrons. Why do they orbit? And how are they arranged in 3D space? Well, the first person to have a realistic model of the atom was a guy named Niels Bohr. His friends called him that because he was boring. Sorry, I won't have any more bad jokes. He came up with a model that looks very similar to the solar system. You have the nucleus in the center, kind of like we would have the sun in the center of the solar system. And then you have the orbitals, which is where the electrons would be located. Only worked for hydrogen. Dull. So his model, although pretty cool, only seemed to work for hydrogen, only seemed to hold up for hydrogen. So the Bohr model, it broke after the first element. Scientists noticed that there were energy anomalies when they were trying to manipulate the electrons in the bigger elements. So anything bigger than hydrogen, they noticed these weird things would start to happen with the electrons when they tried to manipulate them. This led to many questions that could only be answered by quantum mechanics. Now people hear that and they freak out. Don't worry, we're not going to get into the depths of the quantum mechanics, but we are going to get introduced to it. So the basic idea here is that Bohr's model was essentially a two-dimensional model. It didn't hold up in the real world. And there's his model. And what real atoms, of course, are three-dimensional. So how do I draw that? And those of you that know me know I cannot draw, so I really do need help with this. So it was eventually discovered that electrons are both attracted to the nucleus and repelled by each other. So there has to be a model that works. How do all those electrons orbit around the nucleus if they're repelling each other but they're attracted to the nucleus? How do they stay in their orbits? So there has to be an answer, right? 3D. As you can see in this picture, these are the different subshell orbitals. So we had the orbitals in the Bohr diagram, like you can see right there. There's a Bohr diagram. And as it turns out, the Bohr diagram only really represents what is now known as an S subshell. And notice that the S subshell, as you can see, can only hold 2 electrons. So if this was the nucleus of a hydrogen atom, there would be the one. Actually, hydrogen will only have 1 electron, but there it would be. Okay? But as you get bigger and further away from the nucleus, what you notice is that there's more space, and it's three-dimensional space. So electrons aren't just going to be rotating around in a circle. They're going to be going in different areas and different ways. So the second one that you see here, that's called a p orbital. And notice that it goes in several different directions. And also it can hold more electrons than the first one. It can hold 6 electrons as opposed to the 2 that you can see. And as you get further and further away from the center of the atom, you get more and more space, and you can develop even more sophisticated subshells, like the D one here. Now that's only one example of the D. The D would actually have several units that would work exactly like that. Right? And then of course there is another one called the F orbital, which is even more complicated, because you can see it. The D subshell can hold 10 electrons, and the F subshell can actually hold 4. Okay, but right here is a nice example of how the energy levels themselves, the subshells, can come together in an energy level to hold the different electrons so that they don't fight with one another, but yet are still attracted to the nucleus and can stay in their designated paths around the nucleus. So that, in a nutshell, is the basics of quantum mechanics inside an atom.